Ladies and gentlemen, you just received something incredible. It seems we have finally a strong candidate for an Earth-like exoplanet. This distant exoplanet, located in the habitable zone of its star, holds the promise of liquid water and potentially life. If not advanced life, life in some form. The latest discoveries by the James Webb Telescope might bring in some exciting news on this front. I checked on YouTube and no other Indian channel has covered this huge piece of information as yet, and I'm pretty sure we are the first one announcing this in this country at least. So if you're a fan of this channel and want the channel to grow, please do share this video, as you will help spread this information to many people, since a huge number would be unaware of this piece of news. And don't forget to watch the full video for the complete up-to-date information on what has truly been an amazing discovery. I know you are excited, so let's skip the intro for today and get right into the news. Last month, the James Webb Space Telescope detected carbon dioxide and methane in the atmosphere of an exoplanet, K2-18b. Webb's data suggests that the planet might be covered in ocean with a hydrogen-rich atmosphere. This news was published in a paper led by Nikku Madhusudan, a professor of astrophysics at the Institute of Astronomy, University of Cambridge. Before we get into details about what James Webb found, let's understand this exoplanet a bit better, shall we? K2-18b is an exoplanet orbiting the red dwarf K2-18, which is located about 124 light years away from Earth. The planet, initially discovered with the Kepler Space Telescope in 2015, is about 8 times the mass of Earth and is thus classified as mini Neptune. It has a 33-day orbit around its parent star. The K2-18 star has 2 planets orbiting it, K2-18b and K2-18c. This observation has been made on K2-18b. In 2019, the presence of water vapor in K2-18b's atmosphere was discovered, drawing attention of astrophysicists to this system. The first insight into this exoplanet came from observations with NASA's Hubble Space Telescope, which prompted further studies. Now, the latest findings from James Webb has since changed the understanding of the system. This exoplanet can be found near the constellation of Leo on our skies. It is around 21 million kilometers from its sun, which is around 16% of the distance between us and our sun. K2-18b is situated comfortably within the famous Goldilocks zone, the cosmic sweet spot where the planet receives just the right amount of starlight, enough to maintain liquid water on its surface without the risk of evaporation. Even though it is closer to its star, it can still be said to be in its habitable zone, as its star K2-18 is a red dwarf which is much cooler and smaller than our own sun. It is around 45% the size of our sun and is not visible to the naked eye. The amount of light that the exoplanet receives from its sun could be just right for it to support life like what we have here on Earth. But there are some problems. It may not be a rocky planet like Earth and Mars and so on. Even though it is 8.6 times bigger than Earth, it is less dense than Earth. That means it is more similar to Neptune than Earth, with a gaseous atmosphere. If it is rocky, then it would be a ball of rock with a deep and thick atmosphere of hydrogen gas. Or it could be what astrophysicists call a Haitian world, a planet with an ocean with a lot of hydrogen above it. Hydrogen plus ocean, Haitian. And it is not just hydrogen that has been detected. The telescope has also found presence of carbon-based molecules such as methane and carbon dioxide. The abundance of methane and carbon dioxide and shortage of ammonia support the hypothesis that there may be water underneath a hydrogen-rich atmosphere in K2-18b. Another interesting discovery is a possible detection of a molecule called dimethyl sulfide, or DMS. Astrophysicists call these findings as biomarkers. It's a measurable sign that provides us with information about a particular biological aspect, such as the presence of a disease, the effectiveness of a treatment, or the potential of life on another planet. On Earth, dimethyl sulfide is only produced by living organisms and by humans in lab. Although DMS is created in labs by chemists mainly for use in the cosmetic industry, especially to increase the aroma and flavor of certain consumer products. It is used to make fabric softeners, some water treatment chemicals, and some agricultural chemicals. Now naturally, this gets released automatically when you are cooking some vegetables such as beetroot and cabbage. It gives an aroma to tomato ketchup, milk, certain seafood, and believe it or not, beers, especially lager. Apparently, it smells a lot like cooked sweet corn. So, is some Mallu alien sitting on K218b selling lots of sweet corn? Precisely not. The major source of dimethyl sulfide on Earth is not from the sources that I mentioned, and this is what makes it interesting when it comes to detecting this on this exoplanet. The bulk of the DMS in Earth's atmosphere is emitted from phytoplankton in marine environments. Phytoplankton are microscopic single-cell organisms that live in oceans, seas, and freshwater. Phytoplankton are capable of photosynthesis and live in the upper sunlit layer of water. They take up carbon dioxide, make carbohydrates using light energy, and release oxygen. No other geological process like volcanic eruptions or lightning produces any dimethyl sulfide. So if K218b has DMS, then it must enhance the hypothesis that there is an ocean and the presence of phytoplankton and thus life. But Houston, we have a problem. The amount of DMS that is detected is very negligible, almost 0.0003% in concentration, and that throws a shadow on the we found life theory. But there could be something else on that planet that generates DMS that doesn't exist on Earth. The chemistry of production of DMS might be entirely different on another planet than ours. Or there could be an error in the readings. We don't know yet. And science doesn't jump into conclusions based on one observation. It needs multiple evidence. So we need more data before we can ascertain that there are indeed phytoplankton in K218b. Upcoming observations by James Webb should be able to confirm if DMS is indeed present in the atmosphere of K218b at significant levels. While K218b lies in the habitable zone and is now known to harbor carbon-bearing molecules, this does not necessarily mean that the planet can support life. The planet's large size, with a radius 2.6 times the radius of Earth, means that the planet's interior likely contains a large mantle of high pressure ice like Neptune, but with a thinner hydrogen-rich atmosphere and an ocean surface. Because it is a hydrogen-rich atmosphere, the temperature and pressure increase the deeper you go. By the time the rocky core, if there is any, is reached, the pressure would be thousands of times higher and the temperature could approach 5000 degrees Fahrenheit. Haitian worlds are predicted to have oceans of water. However, it is also possible that the ocean is too hot to be habitable or to be in a liquid state due to high temperature and pressure. These conditions are bad news for the formation of complex molecules such as DNA, which aren't stable at high temperatures and pressures. Even if we keep an open mind about the conditions necessary for life to exist, scientists generally agree that complex molecules are essential. They provide the information needed for life to replicate. However, on K218b, we don't have enough evidence that complex molecules can be formed on the planet's surface. So how does NASA and other space centers find what is inside these planets which are so far away? They use a method called transit. They train the telescope to monitor the brightness of stars in a particular section of space they want to study. Let's take the case of K218b itself. When K218b passes in front of its host star K218, it causes a tiny temporary dip in the star's brightness. This is because the planet blocks a portion of the star's light. By analyzing the depth and duration of these brightness dips, scientists can gather information about the exoplanet. For example, the depth of the dip tells them about the exoplanet's size compared to the star, and the duration of the transit provides its orbital period. Spectroscopy is also used to study the light coming from the star during a transit. When an exoplanet transits, the star's light passes through the exoplanet's atmosphere. Some of this light gets absorbed by the elements and molecules in the atmosphere. By analyzing the light spectrum before and during a transit, scientists can identify which elements and molecules are present in the exoplanet's atmosphere. This helps them determine the presence of things like water, methane, or oxygen. The transit method is a really powerful tool in the search for habitable worlds beyond our solar system. It observed 2 transits of the planet as it covered the star and used 2 of its ultra-modern equipment, NIRISs or Near Infrared Imager and Slitless Spectrograph and Near Infrared Spectrograph or NIRSPEC to do this spectrography. One huge advantage that JWT had over Hubble is that while Hubble could only detect things within the range of optical light, JWT can detect infrared emissions too. For a detailed video on how JWT works, please check out this video that I had done earlier. So the molecules that we believe exist in a Hydrogen world are absorbed in the infrared area of the spectrum, and hence Hubble couldn't detect them, whereas JWT could. Now the media has just taken this observation and has begun to circulate that we may have found life on another planet, and I'm sure many YouTubers would also join the bandwagon soon. So I thought, let me set some records straight before the misinformation hits us all. Everyone wants to find out whether JWT has found a biomarker and thus a possibility of life existing in some form out there. But the evidence for it is very small right now. Moreover, the data from NIRSPEC would only be made public in Jan 2024 and NIRS's data in June 2024, 12 months after the observations were made. So it's going to be a while before we can conclude for sure if we have found what we think we have found. But the good news is that because of what we have found, the JWT is going to be making more observations on J218b, especially using its MIRI or mid-infrared instrument, which is capable of differentiating the wavelengths better than the previous 2 instruments. And finally, we may be able to confirm if the contents of the atmosphere of J218b is really what we know today. So let's wait for the next 1-2 years for us to know if we have finally found our Earth's cousin slowly orbiting its star, holding a lot of phytoplankton in its ocean, which are emitting a lot of dimethyl sulfide out to its atmosphere, not knowing that 124 light years away there is another species of life who are observing them and getting pretty excited. Till then, let's just let evidence lead and not spread misinformation that we have finally found life elsewhere. One day we may discover water and maybe even signs of life on a truly habitable exoplanet. Let's please not cry wolf so many times before then that the excitement of the discovery is drowned out. I hope you liked this episode. Please like, comment and share if you found this information new and useful. Please subscribe if you're watching this channel for the first time so that you don't miss out on our new videos. And do check out the older videos that we have done and let me know your feedback. Do support this channel through super thanks, being a member, buy me a coffee or UPI ID. I shall be back soon with yet another interesting science video. Until then, it's bye-bye from Pale Blue Thoughts.